So last time we talked about completing the square, and your homework was questions 1 and 2. What's more important is question 2. So if we look at 2D, for example, we are required to solve, 2E. We are required to solve x squared plus 4x plus 1 equals 0 using completing the square. And as we have learned, the process begins by sending the constant to the left-hand side. So x squared plus 4x equals -1. And I need to check what is the coefficient of x squared. The coefficient of x squared in this case is 1. Therefore, I can complete the square. So I ask myself, what constant do I need to be here on the left-hand side that will make it a perfect square? And the question is, we take the coefficient of x, which is 4, and we divide it by 2, half of it, yani. So 4 divided by 2 is 2. Square it, that's 4. So you add a 4 to both sides. You need to add the 4 to both sides, otherwise you will change the equation. Now, the left-hand side is a perfect square, meaning that it can be written as x plus 2 all squared. This is perfect square factorization. Root of the first, the sine of the second, and the root of the third. Equals -1 plus 4 is 3. Taking the square root of both sides gives me x plus 2 equals plus or minus the square root of 3. And already plus or minus root 3 is in the simplest radical form. Therefore, x is equal to -2 plus or minus root 3. This means that I have two possible answers. X is equal to -2 plus root 3, and you can work that out if you want to, or x is equal to -2 minus root 3. And you can work that out if you want to as well, but the question says leave the answers in the simplest radical form. Let's do 2h. It's x squared plus 8x plus 14 equals 0. Again, we check, we find that the coefficient of x squared is 1, so we can complete the square, no problem. So we send the constant to the right-hand side. It becomes x squared plus 8x equals -14. Next is the step to complete the square. We ask ourselves, what is the constant that will make x squared plus 8x a perfect square? Half of the 8, half of the coefficient of x squared is 4. Square it, that's 16. So you add 16 to the left-hand side. Therefore, you must add 16 to the right-hand side to maintain equality. Therefore, the left-hand side is now a perfect square, and it can be written as x, root of the first, sine of the second, root of the third, squared, and this equals -14 plus 16 is 2. So x plus 4, by taking the square root, is equal to plus or minus root 2. And x is equal to -4 plus or minus root 2. So that is the idea of question 2. There's no more to it, nothing more to it. That's all. Now, the new idea that I would like to present to you now is the following. What if we have something like x squared minus 6x minus 5 is equal to 0. And in this case, the only new thing that is different from the previous questions is that we have a negative with the x term. The x term is negative. So what we do is exactly the same process. X squared minus 6x equals 5. And then we ask ourselves, can we complete the square? Yes, because the coefficient of x squared is 1. What about the constant that I need that will make the left-hand side a perfect square? Well, what's the coefficient of x? It's negative 6. And half of it is negative 3. Square it, that is positive 9. So what you need to do is add x squared minus 6x plus 9. So what you add is always a positive. It does not make a difference if the x term is positive or negative. So you add 9 to the left-hand side, and therefore you also must add a 9 to the right-hand side. Now the left-hand side is a perfect square, and you know this from grade 8. If you want to write the left-hand side by perfect square factorization, the rule is root of the first, x, the sign of the second term, which is a minus, and the root of the third, 3, all squared. Sorry, this is a 9. And therefore, this equals 14. Taking the square root of both sides gives you x minus 3 is equal to plus or minus root 14, and therefore x equals 3 plus or minus root 14. You see, it's exactly the same, only that you have to pay attention when writing the perfect square. There is a minus in the middle. Now, why is that? Consider x minus 1 whole squared. This is x squared minus 2x plus 1. Consider x minus 2 whole squared. This equals x squared minus 4x plus 4. If you multiply them out, and you should do this in your head by now, this is what you get. The remark is that if it's a perfect square, the constant is always a positive. Compare those to the cases when we were working with x plus 1 whole squared. This was x squared plus 2x plus 1. And x plus 2 whole squared was x squared plus 4x plus 4. And x plus 3 whole squared was equal to x squared plus 6x plus 9. So again, here the constant is a positive. And for you to have a perfect square on the left-hand side here, the constant must be positive in both cases. Now, what determines the sign inside the bracket here is this sign. It's a positive here, and it's a positive here. So, one final example. Consider x squared plus, minus 36x minus 12 equals 0. First of all, the coefficient of x squared is not 1. So we cannot complete the square unless we divide by 3. So we divide through by 3. That leaves us with an x squared. So now we can complete the square. Minus 36 divided by 3 is 12x. Minus 12 divided by 3 is 4. Now we send the 4 to the right hand side. That gives us x squared minus 12x equals 4. And we ask ourselves, what constant do we need? Negative 12 divided by 2 is negative 6. Square it is positive 36. So we have to add 36. And on the left hand side again we add the same 36. So the left hand side becomes, as a perfect square, it's root of the first the sine of the second term and the root of the third, all squared, equals 40. Taking the square root of both sides gives us x minus 6 is equal to plus or minus root 40. But this is not in the simplest radical form. So we can say that, okay, this is equal to plus or minus 2 root 10 in simplest radical form. Therefore, x is equal to, take the negative 6 to the right hand side, is 6 plus or minus 2 root 10. So you have two possible answers. One final remark is that you should not be afraid of fractions. For example, two x squared minus 6x minus 5 is equal to 0. In order to solve this, I have to divide through by 2 first, because I need the x squared term to have a coefficient of 1. So if I divide through by 2, I get x squared minus 3x minus 2.5 equals 0. No problem with the fraction. I have a constant that I need to send to the right hand side. So x squared minus 3x is equal to 2.5. Now what constant do I need to add? What's half of negative 3? It's negative 1.5. Square it, and that's the number that you need to add. So x squared minus 3x, and let's not worry about its value for now. We need to add half of the 3 squared, which is 1.5 squared. Note that I did not consider it as negative 3, because when you square, you're going to end up with a positive anyway. And this equals 2.5, and again, you have to add the 1.5 squared. Now you can write the left-hand side as a perfect square. The left-hand side is root of the first, sine of the second term, plus root of the third, which is obviously root of 1.5 squared is simply 1.5 whole squared. Now you need to think about this value. 1.5 squared is equal to 2.25. So this constant is equal to 4.75. Taking the square roots gives you x minus 1.5 equals plus or minus root 4.75, and finally x is equal to 1.5 plus or minus root 4.75. Now this doesn't look very nice, so we might as well calculate it to three significant figures. We have 1.5 plus root of 4.75, which is 3.68 to three significant figures. So x is approximately equal to 3.68, or x is approximately equal to, and we change this to a minus, and this equals negative 0.68. And that's it. This concludes the three methods to solve quadratic equations: factorization, the quadratic formula, and completing the square. Please check EduNation for your homework.